In this video, we'll be talking about how to convert between exponential expressions and logarithmic expressions. So the first thing we want to do is talk about inverses. Inverse functions are functions that undo each other. So one of the most common examples we see is that if you have a function f of x equals x squared, the way you would undo that x to the second power is that you would take the square root of it. So its inverse function is g of x equals the square root of x. So the idea with inverses is just this idea of undoing each other. So what we want to do is figure out what is the inverse of an exponential function, or how do you undo an exponential function? And the answer to that is this new word called logarithms. They're often just called logs. Kind of just shorten it. And we are going to take a look at how we would convert between a logarithmic expression or equation and an exponential equation. So let's start actually on the right side of this little flowchart. So we have b to the x equals y. So over here in this little thought bubble, I kind of have the words that you would use to say that equation out loud. B to the power of x, or b to the x equals y. So you want to rewrite that as a logarithm. Then you would write log with this little b next to it, and then a y is equal to x. And the way you read that is log base b of y equals x. So you'll notice that this b, the b that was the base of your exponential, becomes the base of your logarithm. The y that your exponential was equal to becomes what's called the argument of the logarithm. That's kind of like what you plug into the logarithm. And then this x that was the exponent in your exponential becomes what your logarithm is equal to. So probably the most important of all those words we just talked about is that b is called the base. Okay, so you have a base of an exponential equation. You also have a base of a logarithm equation. And for the purposes of logarithms, b is always greater than 0. So the base is always going to be 1 or bigger. And for the most part, we're just going to be looking at whole number bases as well, which is nice. So let's take a look at why we should even care about this kind of flowchart and cycle, switching back and forth between logs and exponents. Say I want to evaluate log base 2 of 8. So I'm trying to figure out what is log base 2 of 8. So what I'm really asking myself is, what exponent do I put on the 2 on the base to get 8? And the reason I'm asking that is because I know that this 2 in the logarithm, that's the base of my exponential. And this 8, that was what my exponential equation was equal to. So it's kind of like 2 to something is equal to 8. And I want to figure out what is that something, that 2, the exponent that I put on 2 to get 8. Well, since 2 to the third power is equal to 8, it means that log base 2 of 8 is equal to 3. Okay. So let's go ahead and do some practice of just rewriting and switching between logarithm form and exponential form. So in this first set of examples, I'm giving you a bunch of logarithms or logarithmic equations, and we're going to rewrite them as exponents. So I have log base 3 of x is equal to 5. So 3 is the base of my exponential equation. The 5 is the exponent, and it's equal to x. So log base e of 5 is equal to x. Now this e, that looks like a variable, that's just a number. So we're just going to treat it like a number. So be e to the x is equal to 5. And in the next one, I'm going to have log base 3 of 81 equals 4. So I have 3 to the 4th power is equal to 81. So let's go ahead and go work the other direction now. So in the next set of examples, we are going to start with an exponential and then write it as a logarithm. So if I have 5 to the x is equal to 625, I have log base 5, so I'm going to write a little 5 down here, of 625 is equal to x. So notice that this 5, it's kind of like the opposite of an exponent. It kind of just goes at the very bottom. It's called a superscript or a subscript. And it just goes kind of like as a small, almost underlined version of the numbers. Okay, the next one, log base x, so whatever has the exponent is your base of your log, of 64 is equal to 3. And then my last one, log, the 3 goes down here, log base 3 of 9 is equal to 2. And as we'll keep doing more and more practices of switching back and forth between logarithms and exponents, but your key is really going to be just remembering this flowchart up here and where to put the b, the x, and the y. Okay, let's talk about a couple special bases. So you can have any base you want. Any number can be a base. So you could have 7 to some exponent. You could have 132 to some exponent. But there's a couple bases that are just special, and they have special names. The first one is called a common log. So whenever the base is 10, it's called a common log. So the way that we treat that is we actually don't write the base of 10. So whenever you would have a logarithm that has log base 10 of x, you're just going to write log of x. You're just going to ignore the 10. So that means that if you ever see a log that doesn't have a base written in, you're going to assume that the base is 10. So in this example on the right, I'll show you what I mean. If I have log base 10 of 100, another way of writing that is just log of 100. Okay, I don't have to write the little base 10 because it's the common log. The other special base is called the natural log. So the natural log happens when the base is e. So e is a new number for you guys. It's called Euler's number. Euler was a really famous mathematician that did a lot of work to help us understand a lot more about how math and continuity and continuous compounding works. But the important thing is that e is a number. Okay, it's not a variable, it's a number, and it's kind of like pi. So you know whenever you see pi, it looks like a variable, but you know it really represents about 3.14. E is similar. Whenever you see e, it's a number, and that number is about 2.72. So whenever you see the base of e, we're going to replace log base e with just this ln, and the ln stands for natural log. Okay. So the idea is that if you see the ln of x, it's the same as thinking log base e of x. So in this example over here, I have log base e of 5. I'm going to switch out this log base e for the ln. Okay, so this would be the same thing as the ln of 5. Okay, and that's a cursive L, so maybe I should do it in not cursive, so you know that's the ln of 5. And you're going to keep seeing these special bases show up all the time. The reason that we even care about them is that they tend to be the most frequently used bases, and that's why we give them special names and we give them special symbols. Okay, and we're just going to look at a couple properties really fast of logs. It's actually just one property. There's just 3 different ways of writing it. So if I have log base b of b to the x, then I'm just equal to x. So whenever the base of your log is the same as the argument of your log, the log and everything just kind of cancels out and you're just left with the exponent. Okay. Same thing in the next example. I have log of 10 to the 3rd power equals 3. Remember that this log is the common log, so it really has a base of 10. So you can just cancel out the base 10 and the 10 in there. Same with the ln of e to the 5th. The ln is the same thing as log base e of e to the 5th. So essentially everything's going to cancel out except for that 5 exponent, and that will be your answer. So big takeaways from this page of notes is first, how to convert between exponential and logarithms. Second, these special bases, so the common log and the natural log. And then third, this property down here. Okay. So what we're going to do is we are going to do some practice with evaluating logs. So we're basically just trying to figure out what number is a logarithm equal to. And what we're going to do is we're going to place these 5 logs on a number line in their appropriate spot. So to do that, we're going to ask ourselves some questions. So if I want to know what is log base 3 of 3, the question I'm asking is, what exponent do you put on 3 to get 3? The answer to that is 1. 3 to the 1st power is 3. So that means that this whole logarithm right here, log base 3 of 3 is equal to 1. What exponent do you put on 3 to get 9? So 3 to what power gives you 9? That's 2. So this logarithm, log base 3 of 9, is equal to 2. And I'm asking myself that same question for all of these. So what exponent do I put on this 3 so that I get 1/3? And to get from 3 to 1/3, I'm going to have to have a negative exponent. It's going to be -1. And then what exponent do I put on 3 to get 1? 0. 3 to the 0 power is 1. And then what exponent do I put on 3 to get 1/9? So I know that 3 to the second power is 9. And since it's on the bottom of a fraction, it's going to be a -2. So with that information, I can go ahead and put these logarithms on the number line below here. So I know that at 1, I'm going to have log base 3 of 3. At 2, I'm going to have log base 3 of 9. At 0, I'm going to have log base 3 of 1. At -1, I'll have log base 3 of 1/3. And then at -2, I have log base 3 of 1/9. Okay. And you can also just write the A, B, C, D, E letters down there if you prefer to. So again, the big idea with evaluating logs is you look at the base, so that little mini number. You say, what exponent do I put on that base to give me the bigger number? Whatever that exponent is, that's what your log is equal to. So let's do the next one. So 3 to what power gives me 81? So another way to think about this is 3 to what exponent gives me 81? And in this case, it's 3 to the 4th power. And you might have to just kind of try something. You might have to pull out your calculator and do 3 to the 1st power, 3 to the 2nd power, 3 to the 3rd power, 3 to the 4th power, and just kind of guess some. So here in B, I'm looking for 10 to what power gives me 100? Well, that's going to be 2. Okay. Then I'm looking for 8 to what power? It's going to give me 8. Well, 8 to the 1st power gives me 8. 5 to the 2nd power gives me 25. And 2 to the 5th power gives me 32. So I can use that to go ahead and place these logs on the number line down here. So let's go ahead and place them. Maybe you wrote them in as we filled them in. Log base 10 of 100. Log base 8 of 8. There's 2 here at 2. Log base 5 of 25. And then log base 2 of 32. I want you to go ahead and try the next one on your own. So hit pause, try this one, and then come back and check your answers. Okay, in this example, all of your logs ended up as either equal to 0 or 1. So take a second, double check your answer. Okay, in these next set of examples, in example 4, we're looking at a bunch of fractions. Okay, so if you're looking at your argument, which is kind of this bigger number in the log, that's the argument. If your argument is a fraction, then you automatically know that the exponent has to be negative. So I know that any of these that have a fraction as the argument are going to have a negative number. I'm just going to put the answers beneath them. So this is going to be a negative number, a negative number, negative number, a negative number. Let's try to figure out what that negative number is. And to figure out what that negative number is, I'm going to think about 2 to what power gives me 4. So 2 to the 2nd power gives me 4. So 2 to the -2 is going to give me 1/4. 10 to what power gives me 1,000? That's 3. So 10 to the -3 gives me 1/1,000. 5 to the 3rd power gives me 125. And 6 to the 1st power. And then you can go ahead and place those on the number line down here. Looks like I didn't make the right number line. You probably need to add your own -3 down here. So just remember, if you have a fraction as your argument, it means that the log is going to be negative. Okay, the next example is kind of an interesting one because if you look at the 4 numbers that I have here, all 4 logarithms have an argument of 16. Okay, and we're going to look at how does having a different base change what these logarithms evaluate to? So log base 4 of 16, so 4 to what power gives me 16? Well, that's going to be 2. So let's go ahead and write that on my number line. So log base 4 of 16 is going to give me 2. Log base 2 of 16, so 2 to what power gives me 16? That's 2 to the 4th power, because 2 times 2 times 2 times 2 is 16. So over here, I'm going to have log base 2 of 16. Now log base 8 of 16, this is kind of a tricky one. Lots of times people want to say this is equal to 2 because 8 times 2 is 16, but that is not the case. Remember, I'm trying to figure out 8 to what power gives me 16. We're actually going to come back to this one because there's not a whole number power that I can put on 8 to get 16. So we'll come back and talk about that one in 1 second. But I can do the last one. 16 to what power gives me 16? That's just 1. So log base 16 of 16 is equal to 1. So what I'm going to do with C is I want to figure out 8 to what power gives me 16. I'm just going to start trying to guess things. If I said 8 to the first power, 8 to the first power is 8. So that's 8 is smaller than 16, so 1 is too small of a number. If I did 8 to the second power, I get 64. 64 is way bigger than 16, so that's too big of a number. That means that log base 8 of 16 falls somewhere between 1 and 2. Because 1 was too small, 2 is too big. So somewhere between 1 and 2, I'm going to end up with log base 8 of 16. Okay, so at this point, I'm not really interested in knowing exactly what that number is. Like maybe it's 1.1, maybe it's 1.2 or 1.3. What I want to know is what does it fall between? So it falls between 1 and 2. And which one does it maybe seem closer to? I would say it's probably a little closer to the 1. Okay. I'm going to let you guys work through number 6. It's a similar idea where you are looking at the same argument, but I have different bases for all of them. So I'm going to go ahead and pause, fill them in, and then we will come back and look at them together. Okay, so this is the number line that I created. You'll notice that the logarithm, the bases kind of go in descending order. So the bigger the base is, the smaller the logarithm evaluates to. So I have the log, the common log, which is log base 10 of 5, is less than log base 5 of 5, is less than log base 4 of 5, is less than log base 3 of 5, is less than log base 2 of 5. Okay. So I'm going to skip number 7 and we're going to jump down to number 8. Number 8 is actually going to turn out to be super easy for us. Okay, the reason number 8 is so easy is because we can use the very last log property that we talked about. So if I have log base 3 of 3 to the second power, remember I can basically cancel out the log base 3 and the 3 because they're the same number, and this will just turn into 2. So over here at 2, I can put log base 3 of 3 squared. Same thing with log base 5 of 5 to the negative 2. Since the base and the base of the argument are the same, we can cancel those out, and I'm just left with a negative 2. So log base 5 of 5 to the negative 2. So again, I'm just looking at the exponents here because the base is the same as part of the argument. And again, I forgot to have a 3 on here. So log base 2 of 2 cubed. All right. So this one should go really easy. We just got to use the log property. The log property that when the base is the same as the number that has an exponent, then you can cancel them out. All right, on the next page, I'm actually going to let you guys work on this on your own. I will fill in the filled notes and put them on Canvas. But here you're just making some generalizations. So you're just saying, are these statements true or false? And then if it's, and then you need to explain your answers. Okay, so take a minute or two, work through these, and then check your answers on Canvas.